Hello all, this is Srinivasan and today we are going to take a look at JUnit framework, a complete architecture on it and the various features it provides. JUnit. First thing, what is the need of a test case? You develop web services. You develop services, you develop your functionality, you develop various features, artifacts in J2E which needs to be consumed by external sources. Now those external sources need to communicate with the components that you have developed with the reliability that the functionality provided by your components is working as expected as to the business guidelines. So to verify the same, whether your code is performing the same as expected, you write test cases, you verify them. So towards this, one of the tools is Java Unit, JUnit. This is owned by JUnit organization. The structure that JUnit follows is that of SUNIT, small talk unit. SUNIT defines the structure of a test case, which is language independent and platform independent. Hence, SUNIT is not an implementation by itself. It is a generic terminology or a framework or an idea that various technologies can implement it. So be it .NET or be it any other language. And from the Java perspective, it is JUnit, which is following the architectural principles proposed by SUNIT, small talk unit. The combined frameworks available across all the technologies are called as XUnit. JUnit was initially created by Kent Beck, Eric Gama, David Staff and Mike Clark. These were the four people involved in the initial development of the JUnit framework. The current version of JUnit is 4.12. That is the stable release which was released on December 4th, 2014. In comparison to the previous series of JUnit frameworks, which was 3.x based, in 4.x it is mostly of annotations. You don't have to extend the classes provided by the JUnit. All you use is annotations. Also, there is a difference in the package structure followed in 4. series in comparison to 3. series. In 4. series, you have org.junit as the base package structure for all the Java classes provided by JUnit, whereas in 3.x, it is JUnit framework dot as the package structure followed for the JUnits. So let us start by creating a small service called the calculator service, which can be consumed by external sources. The methods will be public. So basically, anytime that the development goes through, test-driven development is the word to go. You need to write your test cases even before you start your development, such that you will have a complete idea as to what has to be the expected functionality, what is that is asked out of the design phase of the product. So this is how a test-driven development will be and will focus on. So let's start creating the calculator service. I have taken a sample empty workspace. Let me add the JUnit distribution. So this will be my four public methods exposed by the calculator service, which can be consumed by the external sources. Now, to create a test case, the first design principle is that I need to have my test cases outside of my source folders. The reason being, when distributing the EAR to the customers, or when deploying the EAR on my production environment, I should not have my test cases bundled in my EAR. It should be out of my actual code which performs the functionality, such that it does not act as an overhead in my production. So I create a source folder which solely holds my test cases. So unlike the version 3.x, in 4.x you annotate the methods that you want to be playing the role of a test case as a test. And this is the package structure followed in 4.x. So now let me instantiate the calculator object. Assert is a class which is the core of JUnit. It is the one to which we supply commands telling what needs to be tested in this particular test case. So it provides static APIs for me to provide commands as to what needs to be actually tested in this test case. So in my case, I'm checking for asset equals. So let me run this test case. It's successful. So let me introduce a bug in here, wherein instead of addition, I'm doing a multiplication. So 10 into 20 would result to me as 200, which is different from 30, which is the expected value, and hence resulting in a failure case. The failed cases are marked by the red symbol, whereas the successful test cases are marked with a green, as you can observe here. To avoid a particular test case from getting run, you use the opposite of it. You could see the difference in the case of attest. You will see that run as an extra option of running JUnit test. To avoid from doing so, you can use the annotation @ignore. And in this case, you wouldn't get that option of JUnit test in the run as list of options. Now that we have seen one of the commands that assert provides, we will also observe 4 more commands that it actually provides amongst the many others that it provides. So let us see next, which is assert true. Assert true checks for a condition, and in this case I'll first check whether 10 is greater than 0. It evaluates to true. Ten lesser than 0 evaluates to false, but you are issuing a command for assert that the resulting expression has to evaluate to true, which is not the case, and hence it will be a failure test case. The counterpart of this assert true, assert false, so which expects that the argument that is sent evaluates to false. So hence your test case is successful. Whereas if I give a true condition, your assert false test case will evaluate to false. The next command that we can see, that we can supply to the assert class, is assert null. This evaluates to true. The test case is successful. Whereas if I supply an object to this, it would evaluate to false. counterpart of assert null being assert not null expects the argument that you send be a not null operator. Hence the test case evaluates to a successful test case, and if you send a null object to that, it evaluates to a failure test case. The fourth option that we can see is assert same. In the case of the assert same, it basically checks whether two objects are pointing to the same reference. So in this case, string str1 being assigned to apple, so those who understand the way literals are assigned to string variables will confirm that though str1 and str2 have been initialized separately to the variables apple, they still both point to the same memory location, and hence your test case succeeds. This is indifferent with the assert equals. Assert equals invokes the equals method of a given class or an object to check whether the arguments passed are equal, whereas in the case of assert same, it actually checks whether they point to the same reference. The fifth command that we could issue to the assert class is note that we made a mistake by importing the assert class from the JUnit framework, which belongs to the 3.x version. Instead, we should use it from the org.junit. Most of the APIs that were provided from 3.x are carried over to 4.x. Added on to it are many other features that are provided in 4.x. So the fifth command that we could issue to the assert class is assert that. Assert that is a very useful component or a command to be used with the assert class, which enables you to give various varieties of commands for checking, including the ones that we previously discussed: assert equals, assert true, assert null, assert same. Added on to it is checking whether an element exists in a given list, checking whether a particular string exists in a statement, checking whether a particular object is an instance of a particular class. These are some of the varieties of commands that we could issue using assert that command. So let me first take the example of checking for a string in a statement. So in this case, I take the input as the complete statement, the my string. Using JUnit matches, I call the contain string for good. And in this case my test case passes. And if I search for a different string which isn't existing in the string, it will fail as a test case. Second possibility that we could use using assert that is of verifying whether a particular element exists in a list. So to do the same, we'll have a list first in hand. So there are two elements in my list, and I supply that list as the first argument to the assert that method, and as a second argument I still use the JUnit matches, and as item I'll now pass 1 to check whether 1 exists in my list. It does exist. When I pass a 3, it fails because it isn't existing. These are the first two varieties that you could use using assert that. The third variant of assert that method is same. So for this I go back to my example on Apple. And I use the API provided by the isSame class. Now the str1 and str2 are pointing to the same reference, so it should be a successful test case. And if I make it point to a different variable, it should be a failure test case. The fourth variant of assert that is for checking whether a given object is an instance of a particular class. So to do the same, I use isInstance of So in this case str1 is an instance of string, and your test case should be pass. And if I make it to be integer, it will fail. The fifth variant of assert that is of using isCollection containing, which is again the same as using or checking whether a particular element exists in my list. and as a first argument I supply my list. As a second argument I supply this happens to be a successful test case, and when I pass a element that doesn't exist in my list, I had a failure test case. So these are some of the variant commands that we could issue with the assert class. Assert class being the root of the JUnit test cases. So next to this, we'll take a look at before and at after. The names of these methods are not mandatory to be strict, can be anything. At before and at after are methods that are invoked before and after every test case is run. So in this case, let me go back to my example of verifying my calculator service. And I issue a command to assert to check. So let me also have one more test case for verifying the subtraction case. So to that, let me supply 40 and 15 as the arguments. So the expected becomes 25. And let me put some log statements in my before and after methods. You would have observed that before and after is getting invoked twice, which means to say that for every test case in our class we have two test cases. So for every case, this before and after is invoked. So what is the benefit of such a feature provided by JUnits? The benefit is that you could observe that my calculator service is getting instantiated twice in my test case. Is it really necessary? No, it's not. So we could have it in a single place instead of writing it in every test case and making basically my test case as very cumbersome, to be looking very cumbersome. I can have it in a single place to be instantiated. and remove from other places. So the same I can use it for my addition and subtraction. So in this case I could write the instantiation logic in one place and have it being used in all other test cases, both instantiation and destruction of resources that are needed by the test cases. So in this case, both my addition and subtraction have been passed without being actually instantiating the calculator object within them. Now, in contrast to this, you would observe that my in before and in before after is getting called twice for my two test cases. Now in the sample that we have, what it means is my calculator service is getting invoked twice. Even though the code is only written once, it is instantiated twice, which means that it is not at the class level. So all I need is it needs to be instantiated only once. So how will I do it? To do the same, I will use my at before class and at after class. These are annotations that are defined at the class level instead of the objects level. So these gets invoked when the class is loaded into the memory. So irrespective of any object. So for this to be loaded or for this to be executed, these methods need to be static methods, as it doesn't rely on a particular object to be existing even before these methods can be called. This is at the class level. These methods need to be called at the class level, and hence whichever member variables that you have thought of instantiating or destructing needs to be static as well. So now you will observe that in before and in after are getting called only once, irrespective of the number of test cases available in your test class, which means to say that my calculator's object is getting instantiated only once. The next feature available and provided by your JUnit test cases is about how do you provide parameterization, how do you provide dynamic values to your test case such that I do not have to change my test case every time that I have to run based on different set of values or different set of data. So how will I do it? So to achieve the same, JUnit does provide a feature called parameterization. So using that, what you do basically is you annotate your class with run with parameterized. This makes your test case to be invoked from the parameterized runner. These are amongst the various runners provided by your JUnit framework. So what is the benefit of this is you can provide dynamic parameters to your test case. So the data provided to this test case will be annotated, will be provided by a method which returns a collection, and you can name it anything. But you need to provide an annotation to it, to that particular method. Annotated it with @providers. So then, in my case, I have two methods basically, 10, 20, two test cases basically, verifying add and subtract functionality. Now for convenience purpose, let me keep both the input values to be 10 and 20. And 10. And in the case of an addition it is 30, and in the case of subtraction it is expected value is 10. So for this to happen, I need to provide the data. (20, 10, 30) my addition result and my subtraction result. And let me return this list, this array of integers as a collection. Now when your runner, your parameterized runner, which is amongst the various runners provided by JUnit, is run, it accesses this data provider method, or whichever method that is annotated with @parameters, and instantiates your test case class with the number of values provided. So as in my case, I am providing 4 values. I'll have to have a constructor which takes 4 parameters and assigns it within itself. Now that I do have my values that were supplied by the data provider used by the parameterized runner to create the instances of my class, and once my instance is ready, I can use my variables to provide same as the input to my test cases. So in this case, I can provide number 1 here, which evaluates to 20, number 2 here, which evaluates to 10, and my expected result being sum, and in the case of difference it will be subtract. So what does this mean? You would have observed that I am providing all the set of values at once, which means to say that these values will be instantiated once. My object will be instantiated by parameterized once, and after instantiation all my test cases will continue to run. So let me run my test cases. It evaluates to true. So let me introduce a bug in my difference method. It evaluates to false. So added on to this is, you can also provide further inputs to the same list. Now in this case, in the previous run that we saw, you would have observed that in the previous run that we saw, you would have observed that there was exactly 0 runs. There was exactly 1 run starting from the index 0. Now let us further provide values. (30 plus 10), which becomes 40, and 30 minus 10 becomes 20. 20 and 5 becomes 25, and 20 and 5 becomes 15. Now in this case, I am expecting a run which is iterating for 3 times. Zero, 1, 2. So what happens is, the parameterized runner invokes this method data provider initially, collects this data. On the first run, it instantiates my calculated test with the values provided here on the first element, and then runs all my test cases. Then it takes the second entry in my collection. The parameterized runner takes the second element in my list, instantiates my calculated test, and then runs all my test cases. And then finally, the parameterized runner takes the third element in my list, instantiates my calculated test, and again runs all my test cases, ensuring that all test cases are run against all the data provided. Now as a final aspect, we'll take a look at providing a test suite for my application. To provide a test suite, I am creating a new package. My test suite can be configured to run any number of test cases. This in contrast to calculate a test which itself forms as the unit of a test case. My test suite happens to be a collection of units, a collection of test cases, ensuring that each one of them is invoked. To mark a particular class as a test suite, you mark it with @runs with suite.class. This is again another variety of a runnable of test runner in comparison to the parameterized runner. And the classes that you want to run, or the test cases that you want to run, in your test suite, you will provide it as another annotation. Ensuring that my calculated test gets invoked from a test suite. It did get invoked by these logs, and you can also verify the various outputs because of the parameterized annotation. So in this particular session, we have completely covered most set of the features that are provided by the JUnit. Thanks.